I'm going to show this in 3 different ways, so hopefully it connects with one of the ways that you looked at it. I think it was Emma yesterday who said, hey, I like looking at tables, or maybe she just started with tables. And so maybe I'm going to put the number of days over here and the amount of money in my account right here. And that's X. And it told us in here that f of X is the amount of money in the checking account. So I'm just going to go ahead and write that. And I know that there are 2 different pieces of information they gave me in here. If I read really slow, it says Pete's checking account showed the balance at the beginning of the month, and it was $180. So I want you to think about how many days is that. Show me with hands real quick, fingers, like how many days is that? So that's the amount of money he had after how many days? Come on. Yeah, it says it's the start of the month, so that means no days have passed. So at 0 days, he had $180. Now, moving on, it also says after 3 days, and actually maybe I'll use a different color here. After 3 days, he had $172.50. So 3 days, $172.50. So I can view this as a table. And anything that I can view as a table, I can also view as a graph. And so if I think about what this looks like graphically, I know there's this 0, 180, so I'm just going to say that's 180. And then I know there's this other spot, which is, like 3 days later. And I don't know, it's at like 172. So, that's not that much lower. Notice how I'm not too worried about making a perfect graph. I just need to know where numbers are. That's it. No big deal. And so I know after 3 days, he's at like 172.50, so it's slightly up. We'll say that's 3 days. And so I know that the graph is going to look something like this, which makes a lot of sense to me, because when you look in that table, what's happening to his amount of money? Yeah, it's going down. So we kind of have that downward trend in the line. And now I could represent it in a table. I can represent it in a graph. I can also represent this as just a pair of points. So I know that after 0 days, he had $180. And I also know that after 3 days, he had $172.50. So I've got numerous ways that I can represent this data. I've got our table, I've got our graph, and I've got just a pair of points. And I don't really like my gray lines. I wanted them to be bigger so we can start to see that division between my 3 different representations. Now, I know my goal here is to write an equation for this. I want to write an equation. So I want, like y equals, but it's actually going to be f of x equals, because that's really my amount of money. I'm just going to go ahead and I'm going to get rid of all that stuff, because we've already done our reading. We've already pulled out our information. So we have already analyzed what do we know. And we also know what we're looking for. We're looking for an equation, and this will give me some extra space to work. So keep in mind, it told us this is kind of, he's going down consistently. So I know this is a linear equation. And linear equations kind of have this structure to them. I can kind of use this natural structure. And in order to use this structure, I need a couple different things. What are those things that I need to find? What are those pieces of information that I really need? Yep, Emma's right. I need the y-intercept. What else do I need?
Slope.
I need the slope. Now I want you to look at the information that we have. Do we have either the y-intercept or the slope? I see some head nodding. Yeah. Owen, what do we have?
Well, in the first one, for the y-intercept, it shows 0 and 180. So we know the 180 is the y-intercept.
Yeah, this is the y-intercept. And we can see it, because that's where the x value is 0. We can also see it right there, the y-intercept on our graph. Maybe I should have used white for my line so I don't get confused with my blue and orange points. So we'll just do that. So we can see it right there. That's our y-intercept. And then again, even as points, we can see our y-intercept, right, when the x value is 0, right? That's going to be our y-intercept. So we already have that information, which is amazing because that means that I can already start to write my equation. I know it's going to look something like this. Now, do we already know the slope? Yes or no? Some of us say yes. That's because you figured it out, right? Which is good. So finding slope, keep in mind we know how to find slope. How do I find slope again?
Rise over run.
Rise over run. So if I know that slope is really rise over run, we can actually use any of these three representations. Actually, what's another way I could find slope?
Change in y over change in x.
Change in y over change in x. Like that. What's another way I could find slope? I mean, these are the same thing actually, right? Olivia, what's your favorite? She's always the one that quotes it. Olivia?
Like, I quote it? Like, what do you mean?
Yeah. There's a formula you say for slope.
Oh, y2 minus y1 over x2 minus x1.
Yeah. So if you think about it, this is kind of like our picture way to think about it, right? That's our graph way to think about it. So I just need to know what my rise and run are. I can see that it's not rising, it's actually dropping, right? And if you think about how much it dropped, it didn't drop a full 10. It actually dropped a little bit less than that, right? It dropped, and if I know the coordinates of that blue point, it's easier to see. So that blue point is at 3, 172.50. And from that, I can see that it actually went down $7.50, and I can see that the run is really 3. So I have my rise over run. If I come over here to our table, I can see that how much the y changed. The y changed by going down 750 because the numbers went down. And I can see that my x changed by going up 3. So again, there's my change in y over change in x. There's my slope, negative 7.5 over 3. And then, and this is the rise over run piece. These are just different ways to say the same exact thing. And then over here, if I use my y2 minus y1, if I use that, because I have 2 points, and that's what this is really a good way to think about it with. I have 172.50 subtract 180 all over 3 minus 0, which again is negative 7.5 over 3. Ran out of room. My bad. Which, no matter which way you choose to think about it, we end up finding that the slope is negative 2.5. And so at this spot, I now have access to everything in my equation because I found my slope and I already knew my y-intercept. And so there is my linear equation for this. What questions, if any, do you have about this? Okay, so this is what I want to know. Is the meaning of the y-intercept, and what is the meaning of the slope there? What do those numbers mean? Thumbs up once you can tell me, right? Because we know that the slope is negative 2.5, but I don't know what that means yet. And we know that our y-intercept is 180. And maybe we're clever and we've kind of already thought about what those mean. So thumbs up once you can tell me what those two values mean for us. So sometimes when I'm thinking about slope, it still helps me to see as a fraction, all right? So negative 2.5 is really negative 2.5 over 1, right? So think about what that 2.5 is and what the 1 is. Think about what we know about slope and all the different formulas that we used to get them. Think about what the different numbers mean there. And again, thumbs up once you can tell me fist means I'm thinking. So I'm wondering what these two numbers mean. All right, show me how many of the numbers you can explain. 1 of them, 2 of them, 0 of them. That's what I want to see at this point. All right. Jack, why don't you explain the one that you feel like you can explain?
The 180 is his starting amount of money.
Yeah. That's how much money he had in the beginning of the month, right? That's what our y-intercept is. It's like kind of that starting amount. So this is the starting amount of money. So he had $180 to start. Now, come up to the slope. What is that 2.5? Think about where it came from. Because if you just think about where things came from, they become super easy. That 2.5, that number in the top, came from this 7.5 down here, right? It just got divided. What did that 7.5 represent?
The rise.
Of what?
The.
Think about units here.
Oh.
Right? Or look at the table. Because we have meaning in the table. Tables are great for that. Isn't that 7.5 how much the money changed? So that 7.5 really represents $7.5, right? And what is the 3 in the denominator? Right there. What does that 3 in the denominator mean? What is that representing? 3 what?
How many days he spent that money?
Oh, so this is really dollars over days. So that means up here with that 2.5, that really is dollars over days. So that really means it's really negative $2.5 over days. What's a way I could read that? Can't we just read a fraction bar as per? Negative $2.5 per day. So what does that mean if I say negative $2.5 per day? What does that mean?
He's losing $2.50 a day.
Yeah, he's probably spending it, right? Hopefully he's not just walking around with a hole in his pocket. But his checking account is going down $2.5 every day. That's what these things mean. So he's probably spending $2.5 a day, and he started with 180. Hopefully the man gets a job. He's going to be out of money at some point in time, you know? So we need to be able to make sense of what the numbers mean as well.